So the real question is, what is a p-value? What does this term mean? And that's kind of a difficult question to answer in a straightforward way, so I'm going to use a metaphor. And the metaphor is going to be using a guy named Bob the fisherman. And Bob has no face and also no head, because I couldn't find a royalty-free stock image that I liked better than this one. So Bob wants to conduct an experiment. Okay? He wants to figure out if the fish in Lake B are significantly larger than fish in Lake A. The reason that he cares about this is because he currently fishes in Lake A, and he wants to know if by changing lakes he can increase the average size of the fish that he catches. Okay? So Bob has some prior information about Lake A. He knows that 60% of the fish in Lake A are small, 25% are medium-sized, 10% are large, and 5% are very large. Now, if Bob cast out his net and caught a very large fish on his first try in Lake B, would we say with 100% certainty that Lake B has larger average fish than Lake A? Who says yes? Literally 0 people. Okay. Who says no, it doesn't? Okay, some people. Who says it could be yes or no? We don't really have enough information to determine that. There we go. That's what I wanted to see. Okay, so the reason why we really don't want to go in either direction very strongly at the very beginning of this is because we know there's a chance that even in the original lake you can catch a very large fish, right? It's a low chance. It's about 5% probability, but it can happen. So if Lake A and B are the exact same, there is a chance that we could catch a very large fish on our first try. And in fact, this idea has a name. It's called the null hypothesis. This is the foundation of all statistics, right? This says the starting assumption is that there is no difference between A and B. Now, it's in terms of lakes, but it can apply to anything, right? It can apply to a particular page, a particular conversion rate, a particular average order value.